This talk was supposed to be in German. I like to train it in English as well, and now you're my sparring partners. Yes, I'm Merlin. I'm a Java software entwickler for above 10 years. Even when I'm that young, I'm still Java enterprise developer for more than 10 years. Glider instructor, volleyball player, father, and a big lover of modern Java, of the new Java language at all. Today I want to speak about a new idea in terms of new to the Java ecosystem, but in general, data-oriented programming is not new. But in the Java ecosystem, it's quite new. A few words before, one warning, there are lots and lots of preview features in this talk, in this listings. If you want to know more about these preview features, here in the front row, there's Falk. Next talk. There are not every preview feature is marked as preview feature because I basically forgot it. But I try to mention them. Another slide problem due to technical, we don't have syntax highlighting on the slides today because it's not my laptop or my laptop, it's working on my machine, but it's not working on the other machine. But I promise I will work on that, and on GitHub currently there's no syntax highlighting, but I promise in the next weeks there will be an update and then there's syntax highlighting. Okay, let's start with the topic, data-oriented programming. What is it? Anybody knew what it is? Anybody know the idea behind it, except Nikolai? Slightly, okay. It's basically in the name, but I'd like to start from the beginning. I like to start from a different way, not from the programming way, but from an architecture and historical way. Historically, Java came from a business language. It's a language back in more than 10 years. There was typically one application that solves a problem of an organization. Whatever organization is, whatever kinds of full company or just one department, but it's tend to be one enterprise application for one organization thing. And it's nothing wrong with that. We have an interface on top. We have a domain model which is slightly cross-cutting concerns, somewhere distributed all around it, maybe modelized in one module. We have a persistence layer because persistence is everywhere the same. And we have modules like the billing, the ordering, warehouse, and there's nothing wrong with that. It gets shit done, gets work done. Only problem is if it is one big monolithic application, it's hard to scale them and hard to update them one by one. So every change in, let's say, the ordering also requires an update for warehouse management. We know that problem that it exists and it is solved. Today, most of the to manage two slide decks at once. Today we tend to do self-contained systems or microservices. Self-contained systems is a bit different from microservices, but it follows the same root idea. We have for every domain we have one application. In these terms, we have for CRM, for customer relationship, we have one UI, we have one domain model and one persistence layer because it may be a requirement to have different persistent technologies due to performance, due to other requirements. Next thing is we have decoupled domain model. So we have a small domain model for every subdomain, for every subsystem. And from there on, we have no coupling between the subdomains. That's great. That's hopefully the reasons why every monolithic to microservice or self-contained systems migration project takes place. I know it is not like this, but it should be. We can even go one step further. Within the cloud, it's even more data-centric, even less process-centric. One AWS Lambda or Azure function just focuses on doing one thing with the import data. Just takes the data, doing things, and publishes to the next. And it only does it on very, very small domain on a functional type. With this thinking on an architectural level in mind, it's very easy to understand data-oriented programming, because data-oriented programming is the idea of we just focus on the data and do small atomic things with data in a programming way, not in an architecture way. So there are very few guidelines which I condensed from a talk of Brian Götz himself. The data-oriented programming it's data, nothing but the data. So the domain model is just data carriers. They have no logic, no additional methods, except the technical required ones. It's a strict separation between data and logic. And that's crucial, because the data modeling can change, but it's not that often. In a small domain, it's not that common to change the data model. It's more often to add additional logic or to change the logic, but it doesn't make sense to change the data model in the same steps as we change the logic. And it looks like functional programming. It's not functional programming, just to stop this discussion. But it's not functional programming, but it tries to look like and borrows some ideas. Okay, let's start with the data-oriented programming in Java in real, because it was only just a little bit of additional information to get you warm, to get myself warm with English. Now we focus on code, because it's data-oriented programming in Java, and you haven't seen a single line of Java until now. And it's not Java itself at the moment. Oh, it's not updating. No problem. So, first of all, we start like in every project. We analyze the domain just to get you started. We talk to our customer, and they say, okay, we have something like Rechnung und Kunde. It's very easy, our invoice system. Okay, we model it like that. But so you have a Rechnung, and then you send your Rechnung to a Kunde. No. We also have internal Rechnungen, like one department buys something from the other department. It's an internal stuff, no money, no real money get moved. So it is different. We put them in a database, and then we are fine. Okay, so we have internal and external. That's a choice. We have two different types of invoices, internal and external. And the external invoice has a reference to a Kunde. Great, we send that out. Wait a moment, we have something like Mehrwertsteuer and Mehrwertsteuerabzugsberechtigt. It's a special term in German, but it's very, very great for this example. Because private customers always pay the same amount of tax. Business Kunden also, but not if they're allowed to not pay tax. Yeah, it's this uncommon, but it's basically just one property. For the record, we could model it a little bit better to reflect these Vorsteuerabzugsberechtigung better within the model, but it's okay for now. So we have our model, we put it into code. I said there are choices for Privatkunde and business customer and internal, external invoice. We model that as an interface. Yes, it is correct that this interface has no methods and no data. It's just the reflection of a type and choice in terms of type. Same for the Kunde. And the classes also don't provide methods. I said they have only technical methods. They don't have business methods here. They just carry the data because they are just data and nothing but the data. And connections. So let's go to code. I promised code. Here's code, not with syntax highlighting, but it's the way how we would define the data model, the part with the invoice in Java with modern Java. We have a sealed interface which reflects the choice between internal and external invoice. And the sealed interface is a technique which gives us the power to control which classes are allowed to implement an interface. It also tells the compiler there's no other type of Rechnung, only internal and external. The internal and external invoices are implemented with records here. Records are implicitly final classes, so the compiler knows, and also we as developer know, that this hierarchy ends at this point. There's no different implementation of an invoice except these two. That comes in handy later. Records are also defined as immutable data carrier. They carry the data they have and have no internal state. So nothing to hide, just the data. The notation of a record is pretty easy and is basically looks like a constructor. That's on purpose. We have every component for the external invoice. We have a Kunde and a Wert, and that's the only data this record carries. There's nothing more, nothing less. We could define extra methods, but we said just technical methods and no business methods, so I don't define methods here. Two-string hashcode and equals are generated automatically. Also accessors for Kunde and Wert and every other component we define here. Next thing with data-oriented programming, it's nothing but the data, and we try to model our data in a term that errors are not statable. That means that we not only avoid null, we enforce that no component can be null and there are only copies of data. We do that with a canonical constructor. The private Kunde canonical constructor down there has no explicit parameters. They're the same as above. The canonical constructor is there for checking the data that gets into the record, like the object require non-null for the name, so we never have a name that is null. And for self-copying, like the list of email addresses, they are copied, and from their pointer, that's an immutable copy, and it's not null. So again, this record is, after construction, is it impossible to have null values or mutable values in there. They could be mutable because the objects in the list could be mutable, but they are strings, so at this point we are great. So we have now a domain model that is immutable and free of errors in terms of it is impossible to produce a state that is has errors in it. Now we still need logic. That's the data part for now. We do logic. That's in logic that implements these. We calculate the tax based on the customer approach. With object-oriented programming, it's just to get you started. It's a long code, and it's probably not the best type of style. I don't put much effort in that, just to get you started. The method, calculate Mehrwertsteuer in Kunde and Doppelwert, this signature will stay the same for the rest of the thing, and it will always implement the same logic. For the first, we only take the private Kunde Private Kunde, it's a check if it is an instance of Private Kunde, then a cast and a delegation to calculate Mehrwertkunde for Privatkunde. Very easy code, but it has a few problems. First of all, we have distributed logic. What I mean, the calculate Mehrwertsteuer logic, which is one chunk of logic, is distributed across two methods. And if we introduce more types, it gets more and more distributed. Yes, that's style. I admit that, but it could be copied in the first line, but again, if the logic gets bigger and bigger, it explodes, simply. Speaking on new types, if we add a new type of Kunde, we have the big problem that we run into this illegal argument exception, because it's not covered. But that's a runtime exception. Hopefully our test covers that, but most times not. Another big problem, if we think about it with a new type, okay, I now have an, I don't know, primary customer or so, and we add them and we think about, oh, we need to add an else-if branch here. Okay, let's copy business Kunde, copy and paste, change the instance of expression, we're done. No, class cast exception, hello. So that's not very great. Let's tackle the first one, the problem with the instance of and the casting thing. Now I use the instance of pattern. That's a pattern Falk will also talk about, and I copied the small logic inside the method just because it's easier, it's better fitting on slides now. Important is the business Kunde there. Kunde, instance of business Kunde, B. That's basically a type check, a cast, and an assignment to a variable B. So no problem, we will never again have this problem if we use this pattern that we check the type but cast it to the wrong type, or other way around. The business Kunde B, the variable B, is only accessible in the branch where it is matching. So in the branch where it is true that this is a business Kunde, so it is the next two lines. That would be the scope of B. There are combinable with not and, but that get really messy, don't do that. At the moment it will be better in the next few years with Java, hopefully, but don't do that right now. Okay, we now have solved the problem with the class cast exception. There are a few other problems. Again, this if-else cascade gets bigger and bigger and bigger with throwing logic, and it will become a really ugly mess. Especially if you introduce new types, we still not have solved this problem. So next, a better fit for these pattern matching and exhaustiveness things is the switch expression. Switch expression is a permanent feature. It's the rehabilitation of the switch control. It now can return types, values, and can be on the right-hand side of the assignment, or like here on a return, a direct return. Big differences. There are now arrows instead of colons. That makes it to be an expression and no longer be a control sequence. And it can work with patterns. That's the exact same patterns, but as you can see, it is a way better fit for switch than for if, because it's just this Kunde above in the switch is a Privatkunde, and it's casted and assigned to P, and then we do something with it. Another thing is the when clause. Down there we have when it is vorsteuerabzugsberechtigt, then null. This when is for additional condition checking. So we have these three branches, they are listed down below. There's no default. Big difference, because they're big difference to the other switch. It is not needed here because it is exhaustive. Switch expressions have exhaustiveness checks at compile time. And that's a great, very, very great thing, because the compiler knows there are only two types of customers, because we modeled it like this with a sealed interface. And therefore, the compiler can say, okay, this switch is exhaustive. There's no path that is not covered. And it also works with the when clause. If we delete the last line, business kunde B, without the when clause, the compiler throws an exception at us. It's not exhaustive here. Add the missing branch or a default branch. And never at default. Never. Because this way, if we introduce a new kunde, type of kunde, the compiler tells us, you missed it. You have to introduce a new branch here because you introduced a new type. So, type safety at compile time and not only on runtime. But there are a few small problems. The big problems are solved. Now we are focusing on easier code, easier work with. We, at the business kunde, at the second case, we only check the property. Why do we need a full customer? We don't have to. There's deconstruction. Deconstruction is the exact opposite of construction, and therefore looks very similar to a constructor, but there's no new, and types are defined. Deconstruction is the step of, I have this object, but I don't want this object in this instance. I don't work with this instance directly, I just work with parts of this instance. Like here, we rip apart the business kunde into a string n, or whatever m, and in whatever no Mehrwertsteuer. Currently that only works on records, and this is the same signature as the record definition. And we tear it apart in the name, in the mail address, and in the ist vor Steuer abzugsberechtigt property. Assign it to the values. We don't work with the business customer direct, we work with the data inside the business customer. That's also nestable. For instance, the name of a business kunde, maybe string is not a very good representation. If we focus on data, we should model the data correctly. Maybe a name of a business kunde should be its own type with own type checking. Like it could be a string name or could be a long name and a short name. So that could also be deconstructed there into long name and short name, so they are nestable in together. So we have again a small problem here. We focus now more on the data, but we focus on, we have a lot of variables here. They are not used, like the Privatkunde above, the string and NMM. We only use the Boolean expression. Let's ignore them. Just ignore them with the underscore. Underscore, for a few releases of Java, it is no longer an allowed character as name for variables. A lot of people, me including, find a way around it. Double underscore is allowed. But only once, which is not great if you want to ignore two variables in the same scope, so it was underscore, 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 and not great. It was no longer an allowed character because it was a early step to allow, in some time in the future, I ignore this variable pattern. I ignore this variable thing, not pattern. And it landed now, this is a preview feature. We ignore the Privatkunde because we don't need it here. We just need the information that it is in Privatkunde for branching, but we don't need the Privatkunde. So we ignore this variable P that we have had, and there were a lot of them allowed, so it just says, don't allocate this variable, I will never use it. On the business kunde, looks the same, is different, that's a pattern. We ignore these data, we don't assess it, we don't work with that, we don't check any type of that, there's a component, I don't care what it is, because I only care about it is a business kunde and it has this variable, this component, this Boolean component at the end, and this one is true. This is the end for Java 21. There will be a few more, I suppose, but I'm not able to tell you how, and even Nikolai will not. But I think that's a very, very great solution compared with the object-oriented way from the beginning. It's very, very short, very condensed, and it's type safe and working with the data in mind. Yeah.
So in the object-oriented way, you would put the method inside the object. Now you would put the calculate method in a calculation service, or where would you put it?
Next chapter, because you use the term service. I will come back to that. I wouldn't do it in the object, because it's not object-oriented in that term, but we will, I have a few slides in the back about integrating it into the real world with enterprise applications. I come back to that. Yeah.
At the beginning you mentioned that putting the calculation into I have a mic. Is it on?
I can repeat.
Okay. So in the beginning you mentioned that you would put the computation into separate methods because it might be more complex. The same argument would hold here. I would put the computation probably into separate methods, which would render the case for conciseness a bit void. And then this code introduces a lot of coupling between the signature of business kunde and the usage here, because if I would change the signature of the constructor, I would need to adjust all patterns, which I don't think is a great idea, so I would like to know your opinion on this. And it introduces coupling between the inheritance hierarchy of kunde and this, I won't call it service, but service. Because I need to recompile it in order to see the compiler feedback due to the exhaustiveness check of the hierarchy. So this coupling also sounds a bit fishy to me. So what is your take on this?
So the question is mostly about coupling between the logic and the data hierarchy here. If you change the constructor of the business kunde, you change the model of the business kunde, because it's not a separate constructor. You change the fields inside the record. If you change your model, if you have a requirement to change your model, I suppose that you, on a small, very small scale of your business methods, also your logic changed. I know, it's very, very, very small points here, yes, but if you change your model, it's very hard to imagine, because in a monolithic, in a big model, it's not working. But if you slice down your model just to one small purpose, in my opinion, it's very unlikely that you change your model without changing the logic working on that model. Because you use your model inside the invoicing system, which basically does calculation of Mehrwertsteuer, producing an invoice email, and sending it. The domain is very, very small. And if you change If you have to change your domain model on so small model, I suppose you have to change your logic, and at least it's a very, very small subdomain where you have your change, because you have decoupled your very small subdomain from your bigger domain, because they are independent models. Because you duplicated, bad word, but you duplicated your customer. You don't have this big customer for customer relations, for invoicing, for ordering, for billing, and sorry, there was some duplication, but for delivery. Just have one customer for customer relations. Yes, that's big. That's probably not good for data-oriented part, but for billing, it's basically here's a customer, here's a number, produce an invoice. That's a very, very small amount of data you need for that from the customer. That's why the customer is this small, and it shouldn't get bigger. But I know in the real world it's getting harder to enforce that. It's in different thinking. Your model is very, very small then. You have to tinker with it on your own. Okay. One thing I would like to show, it's more of a thing you can do with modern Java, which I'm just experiencing and playing around with, is these string producing and these string, not interpolation, templates and string processing. And it fits in here, and it is in the repository, so I try to put it there. This FMT, that's a string processor. It gets a string and puts and evaluates the expressions in it and puts it into this string. FMT, I use FMT here because I also use the formatting options of string. And there's one part which I think nobody would do, but it is possible. The switch part, just to get the name out of it. I found it very, very interesting that it is possible. I wouldn't personally never do that, but it is possible. It is important to notice that strings are now able to have expressions in it. They're evaluatable, and we have string interpolation in some term, but it is way more. It's an own scope, and you can implement. You can basically write functions in it and call them and do whatever you want. I wouldn't do that. I would do basic adding like Werte Mehrwertsteuer and not put a switch expression in it, but it would be possible. Found that funny. Next, we have this real world stuff. It's not that high level real world because it's just 45 minutes. But I've done that in this more data-oriented, more data-focused way of programming into projects now, and I think it is great, even in a great match, together with the enterprise way of programming and together with the other features of object-oriented programming. First thing I want to show is testing. Yes, I know. Tests like these are also possible with traditional object-oriented programming. There's nothing data-oriented special about it. What for me is special about it, this Mehrwertsteuerrechner calculate method, it was, in some questions it was stated as, yeah, that's a service. Yes, that's basically the business logic. True. But this is a business logic which don't need additional code. It just needs Java SE and a little bit of JUnit above. And it's very easy tests. To test this calculate Mehrwertsteuer method to 100% coverage, there are only 6 tests. And we are done. And the business logic is fine from there on, because we have not to deal with now. There is no now. We don't have to deal with changing data in between. It's just the input data and the output data. It's very easy, and there are 3 types of Kunde: Privatkunde, Businesskunde, and Businesskunde without Mehrwertsteuer. And then let's take 2 different amount of monies, and we are done. 6 tests done with the business logic. Next is we should group them in modules, and now we're on the bigger level again. We have components like the Mehrwertsteuerrechner and the invoice sender, and they expose just a very, very small API. In this case, just one method call and two different classes. And we can embed them in a bigger invoicing system. We have a processor, whatever you want to name it, which is a service, a controller, or a method on message-driven bean, which takes the incoming data, transforms it into our internal, very, very small domain model, do the statically defined methods, operations on it, which are 100% covered and very easy to cover, and then sends it back. So the test we have very, very high coverage of tests on the domain level, and we can say, okay, we just do very, very thin testing on the expensive integration testing with Jakarta EE or Spring. We don't need a fully blown setup just to test our business methods, because they are just technical stuff that we can test with these CDI containers. The easy part to test is done with easy testing. This is one of the integration. Yes, there could be we could again put these calls for the formatting and the calculation inside an own servers, but it's better fitting on a slides like this, and I think everybody can do this small step. We have this resource. It has the standard injection points for, let's say, a Kunde repository and a mailing service. We get a request, please send an invoice to this customer about this value. Yes, I know there might be a little bit more information, but we can load that from a database as well. So we tell, please, Kunde repository, find us our customer by ID. We load them, populate our very small model for the subdomain, put it into the Mehrwertsteuerrechner, get the value back, put it into the formatter, get the value back, and send the mail out. And on this point, again, the testing is very easy, because the real business value is inside the calculate Mehrwertsteuer and the formatting. That can be tested really, really fast just with JUnit in about, even if you write a lot of tests, a couple of seconds. And the technical stuff, like finding the Kunde and sending the mail, that's just standard stuff. We usually, with Spring, we usually don't write these methods, so just add happy path tests to it, maybe. And that are the expensive tests that run about, not a couple of seconds, a lot of seconds, up to minutes. And I would say that's a great way to also lower your build times by lowering the seconds of testing. So, few final thoughts from my point. There's something to get used to it, because it's a different thinking. We thought, yes, the model can populate, yes, but just focus on that. It's a very, very small subdomain. You have to focus on very small subdomains, otherwise it's maybe not the right tool. It's again just one tool, it's not the tool for everything. You may have a problem with readability because of the new syntax you should use, otherwise it's not that great to program in that way. Just learn it, get used to it. Yes, there might be duplication, like the customer We might introduce a customer in every subdomain. I wouldn't use a shared model there, because that's coupling between modules. That is even worse than coupling in business logic to the model. That's always the case, I think. If you don't have coupling between submodules, this coupling doesn't be this big of a problem. Yeah.
How would you name the customer, for example? Would you do customer, I don't know, like if you have the customer in different modules of the application, would you then do, I don't know, invoice customer, would you do CRM customer, or would you just have customer 5 times in your application? Because then I think, okay, I'm in IntelliJ, I search for class, and now I have 5 customers.
That's something up to you and your team. I personally would name them customer and work with the package name, but that's up to you. Because I don't like these very long names. It introduces very, very long names. If you just add them, if you work with package names, you just have this short name, have it from a package name. If you work with Java platform modules, you can try to minimize the impact of the customers, because you have one scope where this customer is used and one scope where this customer is. At some point, you have this all to come together a point, but yeah. I don't think that's enough value to get these fully blown dynamic data modeling again. So I would stay with customer. In my case, in our project, it's very, very had a big impact on the testability, because the colleagues focused on writing very small methods which are combined together, and these very small methods are very easy testable to high coverage, and the execution time of tests also decreases if you write just Java SE tests and very few integration tests, just because you need an CDI. And performance, a lot of people said, yeah, that couldn't be that performant. I can write better performant tests like they do with streams. I can write a faster for each loop than you will ever write, and then your stream will be. First point, there was discussion on DevOps about that, and it was not possible to make a solid case against streams with for loops. And the very, very important thing is, don't guess, measure it. Write it like that, and if it's performant enough, why treat the worth readability or the clustered logic just for a few milliseconds? Okay, from there on, all this code is on GitHub at data-oriented programming. It gets updates with every new Java major release, and it also might get an update on this integration with Jakarta IE or Spring thing I showed you. And from this point, I think you can try to start with it, try to tinker with it, and get started with data-oriented programming. Maybe it's just the point that you say, no, that's not for me. I'm totally fine with that. But I think you have to heard about it. At this point, I'm done, and I'm here all day. I think we don't have time for questions now.
I guess we have time for 2 or 3 questions, if they're short ones. None. Well then, thanks, Merlin.
If not, I'm here with cookies all day.